Lesson 5-5, Example 1. Our objective is learning to solve equations by adding and subtracting fractions. So here we have x, a variable, plus 5 3/5 equaling 14, and we want to know what x is, what x equals. Well, if we had, sometimes it can look a little scary to see a fraction in a problem like this, but if we know how to do this with whole numbers, our process is the same. If we had x plus 5 equaling 14, we would know that we would need to do the inverse operation. So we would subtract 5 from both sides. We would end up with x equaling 9. We do the same thing with this problem here. We're going to do the inverse operation, and the inverse of addition is subtraction. So we're going to take away 5 3/5 so that we get our x by itself. And since we do it here, we're also going to do it on this side of the equation, since we're going to keep it in balance. So 5 3/5 minus 5 3/5 is going to be 0. So that just leaves us with x on this side of our equal sign. Now we have 14 minus 5 3/5. Well, we know how to do this. We're going to need to do a little regrouping. Instead of thinking about this as 14, I'm going to think about this as a 13 and 5/5. So that way I have some fractions over here that I can take these fractions and subtract from. So 13 and 5/5, remember this is one whole, it's going to be the same as 14. I'm just looking at it in a little bit different way. So 5/5 minus 3/5 is 2/5. And 13 minus 5 is 8. So x is equal to 8 2/5. Now, I can double check this solution. I can put this back in for x. So I could say 8 2/5 plus 5 3/5 should be equal to 14. That's the question I'm trying to answer. Is this the same amount as this? So I can say 8 2/5 plus 5 3/5. Add those together. 2/5 plus 3/5 is 5/5. 8 plus 5 is 13. 5/5 is the same as 1. So I can simplify that to 14. And that is right there. So yes, that is a correct solution. So yes, x does equal 8 2/5. It's always a nice idea to do a double check with these types of problems. Well, let's take a look at one more. Here we have a subtraction problem. We have 3 2/9 equaling x minus 4 1/3. We again want to get x by itself. In order to do that, we're going to do the inverse operation. And the inverse of subtraction is addition. So I'm going to add 4 1/3 to each side. And 4 1/3, if I take it away and then I add it back in, that cancels each other out. So I'm just left with x on this side. And I have 3 2/9 being added to 4 1/3 over here. So I'm going to rewrite this a little bit, give myself a little bit more space. So 3 2/9 being added to 4 1/3. Well, I have unlike fractions, so I need to find a common denominator. And I notice that 9ths here is, I can use that as my common denominator. So I'm going to keep my 3 2/9, and I'm going to make 1/3 and turn that into 3/9. And I am adding those two numbers together. So 2/9 and 3/9 is 5/9. And 3 plus 4 is 7. And remember, we were trying to find out this problem right here was equal to x. So x is equal to 7 5/9. And again, I could go back and double check. I could take 7 5/9 and put it back in and run through this, and when I finish it, so 7 5/9 minus 4 1/3, and I should come up with 3 2/9. It's always a good idea to double check. I'm not actually going to show it here though. Let's take a look at one more here. Here we have 6 1/6 equaling m plus 7/12. Well, I want to get m by itself, so I'm going to do the inverse of addition, which is subtraction, and subtract 7/12 from both sides, which leaves me with m by itself and 6 1/6 minus 7/12 on the other side. I'm going to rewrite that vertically, give myself a little space to work. So, I need to find a common denominator. I think I'll use 12ths. So I'm going to turn my 1/6 into 12ths, 2/12 to be exact. I'm going to keep my 7/12 the same, and I'm subtracting here. So I'm taking 6 2/12 minus 7/12. Well, I can't take 7/12 from 2/12. So I'm going to take a whole from my 6 here. So I'm going to make that a 5. And that whole that I'm taking, rather than thinking of it as a whole, I'm going to think of it as a fraction, and I'm going to think of it as 12ths. So that would be 12 12ths. So it's like this. And 12 12ths plus 2 12ths would be 14 12ths. My 7/12 again stays the same. Now I can say 5 14 12ths minus 7/12. 14 12ths minus 7/12 is 7/12, and 5 minus 0 is 5. So m is equal to 5 7/12. And if I want to double check that, I take my 5 7/12, put it in here, and add these together, and I should come up with 6 1/6. But I'm going to go through one more problem. Here I have w minus 4/5 equaling 3 3/10. Well, I want to get w by itself, so I'm going to want to get rid of this 4/5 by adding in a 4/5. If I'm taking 4/5 away, I'm going to add it back in, and I'll end up with w by itself. Now I have 3 3/10 adding 4/5. Unlike denominators, so I'm going to use tenths. I'm going to change 4/5 into tenths, which would be 8/10. So I have 3 3/10 adding 8/10. So 3/10 plus 8/10 is 11/10. 3 plus 0 is 3. So w is equaling 3 11/10, but that's not the most simplified form. And I want to write it in simplified form, because I notice that I have 11/10. That's greater than a whole. I can pull 10/10 out of there and think of that as a whole. So I'm going to have 4 1/10. 4 1/10 is equivalent to 3 11/10. So my final solution is w equals 4 1/10. If I wanted to, I can put that back in to my original equation and prove that 4 1/10 minus 4/5 does equal 3 3/10.